Find the four smallest positive integral values of a so that the equation ax squared minus 2x minus 3 equals 0 has rational roots. So remember that in order for something to have rational roots, I can look at the discriminant to determine if it's going to be rational or irrational, if it's going to be real or imaginary, and I can also tell the number of roots as well based off the discriminant. The discriminant, remember, is based off the quadratic formula. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. The discriminant is just simply the part underneath the square root. So the b squared minus 4ac, the part under the square root, is going to be your discriminant. So I know that if the discriminant, or the part under the square root, is going to be positive, you're going to have a real answer. If it's going to be negative, you're going to have an imaginary answer. If it's going to be rational versus irrational, I can tell that because if this is a perfect square, then I'm going to have a rational answer. So say this is 16, the square root of 16 is 4, that is rational. Whereas if it's 17, well, square root of 17 is 4 point something something, goes on forever, that will be irrational. So I know that in order for this to be having rational roots, I need to have a perfect square. So b squared minus 4ac must be a perfect square. Well, in this case, b squared minus 4ac, b is going to be the part with the x term, so b squared would be negative 2 squared, minus 4 times a times c. C is negative 3, the constant term, and that's going to be equal a square number. So this would be 4 plus 12a, we know must equal a square number. So we look over here at this little table we created, 4 plus 12a, we're trying to find the value of a so that it will make it rational. Okay, so if I plug in, let's say, a 1 for a, I'm going to get 12 times 1 plus 4 gives me 16. So 16 would be a perfect square. If I take the square root, I get 4. So this 1, if a is 1, that would give me a perfect square as an answer. So I do that and try to find the four smallest positive integral values that will make this happen. So I just tried different numbers, tried 2, if I plug a 2 in I get 28, if I plug a 3 in I get 40, a 4 in I get 52, a 5 in I get 64. So 64 would be a perfect square, right? I can take the square root of 64, I get 8. So this would be my second value. And then I keep going, I keep plugging in a 6, I would get 76, plug in a 7, I get 88. Plug an 8 in, I get 100, and 100 would also be a perfect square. That's the next perfect square. So then we know that 8 would give me that answer. So I have 1 would give me a perfect square, 5 would give me a perfect square, 8 would be a perfect square. I keep trying different numbers, 9, 10, 11, 12, 13, 14, 15. Those would not give me perfect squares. But if I plug a 16 in, I'd get 196, and that's going to be another perfect square. That's, the square root of that would be 16, or 14, sorry, 14. So with that being said, 1, 5, 8, and 16 would be your four smallest integral values so that you have rational roots, and that would be your final answer.